Welcome to a screencast on calculations and significant figures. Whenever we do a calculation, such as the density calculation shown here, we always want to round the answer, round our calculated value, to the correct number of significant figures. And we do this to indicate the precision and/or accuracy of our result. And in general, our answer, our result, can only be as precise or accurate as the least precise or least accurate value that went into that calculation. Now, how does this actually work? How do we do our rounding off when we're dealing with calculations and different numbers of significant figures in our values? And the generalization is, whenever we do a calculation, we always round our answer to the least precise value of all the original numbers used in the calculation. And if we are multiplying or dividing, then the least precise value corresponds to the number that has the smallest number of significant figures. And let's look at an example to illustrate this. If we multiply 3.285 centimeters by 7.4 centimeters, so we're doing an area calculation, when you multiply the two numbers together, you'll get 24.309 and more digits that your calculator will show. And you're multiplying a length in centimeters by another length in centimeters, so you will get an answer in units of centimeters squared. And now, to round this off properly, we note that 3.285 is a value with 4 significant figures. 7.4 is a value with only 2 significant figures. So 7.4 is much less precise than 3.285. So our answer needs to reflect that, and we're going to round off our answer, our calculated value, to 2 significant figures, which means our answer here is 24. 2 significant figures, and then of course centimeters squared for the units. Now, if we're adding or subtracting, we're again rounding the answer to the least precise, but for adding and subtracting, this corresponds to decimal place. And the least precise decimal place corresponds to the largest decimal place in the original numbers. For example, tenths are less precise than hundredths. Hundredths are less precise than thousandths. Thousandths are less precise than 10,000ths, and so on. So, for example, if we are subtracting 35.3608 minus 32.43, what's our answer and what are the correct number of significant figures? And this might be easier to see if we set up the subtraction like we did back in elementary school when we learned how to add and subtract numbers. And you line the numbers up, the hundreds column, the tens column, the ones column, the tenths, the hundredths, all lined up with each other, decimal place in the same location. And then we do our subtraction, and the value that you get is 2.9308. Now, how do we round this off? Well, if we look at the top number, it has 6 significant figures, but what really matters is we know it to the 10,000ths place. The second number has 4 significant figures, but what matters is we know it to the hundredths place. And the hundredths place is much less precise than the 10,000ths place, so that's where we're going to have to do our round off. And notice that when we do the addition, here the thousandths place of 0 and the 10,000ths place of 8, the calculator gives those values, but we really don't know what those values are at all because we didn't have any idea what the thousandths or 10,000ths place were for the 32.43 value. So those were uncertain. That makes the thousandths and 10,000ths place in the answer uncertain. And that's kind of at the heart of significant figures, is your answer can only be as good as the least, or in this case less, precise value of your numbers that went into the calculation. So we're going to round this off to the hundredths place, which means our overall rounded off correctly answer is 2.93. This happens to be a 3 significant figure number, and notice that our original numbers had 6 and 4 significant figures respectively. Our answer happens to have 3, but that doesn't really matter. What matters is our answer is known to the hundredths place. Okay, now what happens if we have mixed operations? We have an addition and or a subtraction and or a division and or a multiplication all jumbled together in the calculation that we do. Well, for mixed operations, we follow the rules we just learned: multiplication division rule, addition subtraction rule, and then we combine those according to the mathematical order of operations. So, parentheses first, multiplying and dividing before adding and subtracting, those sorts of things. And here's an example. This is a density calculation. An object was weighed. It has a mass of 87.317 grams. It was submerged in a graduated cylinder that originally had 8.6 cubic centimeters of liquid in it. The new volume after the displacement is 18.3 cubic centimeters. So the volume of the object is the difference between those two volume values. And when we divide the mass by the volume, we get the density of this object. Okay, so let's set it up here as a fraction showing our two separate calculations. And of course, what you do first is the subtraction in parentheses. And 18.3 is known to the tenths place, 8.6 also known to the tenths place. So the value that we get, 9.7, is also known to the tenths place. We use the addition subtraction rule, rounding off to the least precise decimal place. Then we can do our division, and 87.517 grams has 5 significant figures. 9.7 cubic centimeters has 2 significant figures. We divide this, and the calculator will show 9.022, lots of digits, but a 5-digit number divided by a 2-digit number is going to round off to a 2-digit or 2 significant figure value. And so we round off to 9.0, and of course the units are grams per cubic centimeter. And notice that 2 sig figs, and yes, the 0 needs to be written. That's a significant figure. It's not 9.1, it's not 8.9, it's 9.0, and we know it's two significant figures. And let's do one more example for kind of practice, and maybe think about this as we're going through it, and see if you can predict what we do at each point. So 108.3 minus 74.54 in parentheses divided by 12.60 plus 6.3382 in parentheses. And we start with the parentheses, and 108.3 minus 74.54 is 33.76. But we did a subtraction. We know the first number to the tenths, the second number to the hundredths, so we need to round off to the tenths, and since it's 0.76, we're rounding up to 33.8. Now next we do the other thing in parentheses. 12.60 plus 6.3382 is 18.9382. 12.60 is known to the hundredths place. 6.3382 is known to the 10,000ths place. That means the less precise value is to the hundredths, so we round to the hundredths. And again, 0.9382 rounds up to 0.94. Now, once we've done the two things in parentheses, we do the division of 33.8 divided by 18.94. Calculated value is 1.78458, and of course more digits. And we are dividing a 3 significant figure value by a 4 significant figure value. So we round the answer to 3 significant figures. And 0.78458 rounds down or stays at 1.78. So that's how you do significant figures in calculations with multiplication and division, addition and subtraction, and them combined together. And so that's it for the Calculations and Significant Figures screencast.